These are the Chapter 7 notes 2 on expected values. Today we're going to talk about what an expected value is. And for our example, we're going to take a look at the game show The Price is Right. On this game show, contestants can win varying amounts of money on the game Punch-Out. The contestant selects from among 50 different spaces on the board, each of which contains a slip of paper with an amount of money written on it. Let's take a look at this game show in action before we get into an example.
One, two, three, one more punch, four. Good luck. Well, she went right to the center of the board to start out. We have a $500 card for you. $500. But look, we have 9 more of those. We have all the ones that are higher than that, a few below it. Do you want to keep this, or do you want to throw it away and try for more?
Throw it away.
You just threw $500 away. I know. Really daring to throw $500 away like that. Then you went to the top left corner. People always scream, "Go for the corner," like we've never heard that. Hey man, $5,000. Wow. Now you have a really big decision to make. There's 3 more of these and a couple more higher, and everything else is lower. Do you want to keep this or throw it away and try for more?
I want to keep it.
Keep the $5,000. Good for you. Just got $5,000 going for a quarter spot. Well, the other one was right down here, right? So if you would have thrown away that $5,000, you would have got, $250. Then you would have felt really bad, and you would have said, "Don't throw that away." Then your heart would have sunk. Then I would have went to this last one, and you would have got $5,000 anyway. Congratulations. She picked 2 $5,000 spots out of the whole board. That is amazing. We're going to spin the wheel right after this. Don't go away. Nice job.
So we just watched an episode of this game. Let's find the expected winnings when playing this game. Now, our contestant won $5,000, and below is a table that lists the different amounts of money that can be won and the probabilities of winning each amount. You can see the highest amount that a player could win is $25,000, and the lowest a player could win is $100. The expected winnings, abbreviated E of X, or the long-term expected payout, is actually another word for the mean, mu sub x, or average amount that a person would win if they played this game over and over. The formula for expected value is E of x equals mu sub x equals the summation of x sub I times p sub I, which is really a big fancy way of saying take each x value times its probability and then add these products together until you get to the very end. And the formula works by multiplying each x value by its corresponding probability, then adding these products together. So let's take a look at it in this situation. If we consider money to be the x variable, then to find E of x, what we're going to do is we're going to take each dollar amount, like $25,000, and we're going to multiply it by its corresponding probability, which is 1 over 50. The summation means we are then going to add it to the next product, which would be 10,000 times 2 over 50. And we're going to continue to multiply these dollar amounts times their corresponding probabilities. We're going to add these products together until we get to the very end. So this is the formula that would crunch out the expected value, the expected winnings, the mean amount that a person would win if they played this game. We'll take a moment, type this into our calculator as well, and see what this final value is equal to. And the answer we get is $2,060. We'll write that value right underneath our answer right here. And for this game, on average, E of X is the expected winnings if you were to play over and over again. So if we were to continue to play this Punch-Out game, on average, we would win $2,060 per each draw. Tonight on your homework assignment, you're going to continue working on the rest of the problems on this worksheet, starting with number 1, And you're going to calculate the expected value by using this formula of multiplying each x value times its corresponding probability. What do you do if you don't have a chart? Well, in some cases you have to make one. So in the case of number 2, when there's 600,000 tickets that were sold for this game, there are 6 grand prizes, so the probability of winning $1 million is 6 out of $600,000. You might consider making a chart like this first and then transfer it into your expected value formula. And that's how you calculate expected values.